Techniques used to find the solution of a network. There are basically two techniques we use: mesh analysis, node analysis. If a network consisting of a large number of voltage sources, we use mesh analysis, whereas a network consisting of a large number of current sources, we use the node analysis. So in mesh analysis, we convert, if there is any current source, into equivalent voltage source. If there is any voltage source, we convert that into current source. Now you can refer the source transformation video of how to convert a voltage source into current source, as well as current into voltage source, that Vs into Is and Is into Vs. The link is given in the description below. Let us see what is mesh analysis. A mesh is defined as a loop which does not contain any other loop within it. And the loop analysis is applicable only for a planar circuits. So what is a planar circuit? A circuit is said to be planar if it can be drawn on a plane surface without crossover. Drawn on plane surface without crossover. So we can apply mesh analysis only for the planar circuits. And the non-planar is nothing but non-planar cannot be drawn on plane without crossover. If you observe 1 and 2 and 3 in these three circuits, first one is a planar circuit. This can be drawn on a single plane and there is no crossover. So this is a planar circuit. The second one is having a crossover and this cannot be drawn on a single plane. So this is a non-planar circuit. This seems to be non-planar since there is a crossover, but this can be drawn on a single plane simply by connecting these two with R5 by removing this. So this is again a planar circuit. So to do a mesh analysis, step 1, that we need to check whether the given circuit is a planar or non-planar. Here we have taken this circuit for an example, and this is a planar circuit. So we can apply mesh analysis. Step 2, select mesh or loop currents. Circuit, I am selecting a loop current of I1 here and of I2 here, having the loop currents I1 and I2. Step 3, write Kirchhoff's voltage law equations for the selected loops. So we have a loop of loop 1 is AB, EFA, and the loop 2 is BC, DEB. Now writing the KVL for this, yes, with the source voltage which is equals to the voltage drops, that is I1 through the R1, whereas R2 is consisting of two voltages, that I1 is coming from top to bottom, whereas I2 is coming from bottom to top. So in opposite direction, I1 minus I2. This for loop 1 equation. So if you arrange this, Vs equals to I1 R1 plus R2 minus I2 R2. Now for the loop 2, there is no source, so 0 equals to R3 I2 plus R4 I2 plus this R2. Now I2 is positive and I1 is in opposite direction is negative. So if you rearrange this, minus I1 R2 plus R2 plus R3 plus R4 I2 equals to 0. So we got two equations, 1 and 2. By solving these two equations, you can get values of I1 and I2. For our circuit, we have a graph, 5 branches, 4 nodes, including the reference node. Number of mesh equations is given by the branches minus node minus 1 of. Then we have 5 branches, 4 nodes minus a reference node. You are going to get 2 equations. So this is the formula for linearly independent mesh equations. Example, using the mesh analysis, determine the loop currents for a given network. So we have a network, then the step 1 is this a planar or non-planar? Yes, it is a planar circuit. So second one is selecting the loops. So this is my loop 1. So current is I1, this is I2, and this is I3. So we have a loop current I1, I2, and I3. Next step is writing the KVLs. 3 volts is equals to 10 I1 plus 5. The both currents are coming from top to bottom. So I1 plus I2 plus 3 volts in the first loop. So 3. This current is coming from top to bottom, whereas this one is going from bottom to top. So I1 minus I3. For loop 2, so 10 volts equals to 2 I2 plus 5 I1 plus I2 plus 1. This is in this direction and this is also in the same direction. So plus I3. And the third loop, 5 volts equals to, since the correct direction is in opposite direction, I'm taking a negative voltage. 1 I1 plus I3 plus 3. These two are in opposite directions. So I3 minus I1. So after simplification, you are going to get 18 I1 plus 5 I2 minus 3 I3 is equals to 50. 5 I1 plus 8 I2 plus I3 is equals to 10 minus 3 I1 plus I2 plus 4 I3 equals to minus 5. According to the Cramer's rule, I1 is given by replacing the first term with the voltages. That is a 50, 10 minus 5. And the second one is a 5, 8, 1. Third one minus 3, 1, 4. Divided by the del. 18, 5 minus 3, 5, 8, 1 minus 3, 1, 4. So 50 divided by 32 minus 1 plus 5 minus 5. These two. 5 multiplied by 1 into minus 5 is minus 5. 4 into 10 is a 40 and minus plus minus 3 of minus 40. So plus 40 divided by 18, 31 plus 5 minus 3 minus 20 plus of minus 3 5 plus 24. So 1550 minus 225 minus 150 divided by 558 minus 115 minus 87. So the value is 1175 divided by 356, which equals to 3.3 amps. This is the value of I1. Similarly, you can find out the I2 by simply replacing the middle column with the voltages. Here you can see divided by del of the same matrix. Here the third column is replaced with the voltage. Then if you solve this, you are going to get minus 0.997, 1.47